Yes, good to, yeah, for your information. Welcome, everyone. My name is Fikret Sivrikaya. I am the research director here, and what we wanted to do today is actually to give you some idea first about where you are at, what is ZEKI, who we are, what we are doing, and then a brief introduction about the GoKI project. And the main part is then my colleague Nils presenting a paper about explainable AI. Very nice to have you here. We weren't sure how many would show up physically. We had many registrations on the meetup page. We also announced this through other channels. And it's our first meetup as well. But we have been running this project and also having some workshops, mainly online in the GoKI project already. And it's nice to see already many faces physically here at ZEKI. And I think in the next iterations, and we do actually this every month or so. So periodically, at least until the end of the project, which is running until the end of the year. We would like to hold such events where we would do often these kind of paper reading sessions, but also maybe give you then more insights, more detailed insights about the project itself, the outcomes we will be able to present more concretely towards the end of the year. So yeah, welcome once again. And first, ZEKI, Centrum für Erlebbare KI und Digitalisierung, so that's Center for Tangible AI and Digitalization. As the name implies, the main idea here is to try to bring AI closer to all kinds of stakeholders and make it more tangible. And our approach in ZEKI in doing this is through these four pillars. So the first one is the real labs, real laboratories, and I will talk about that. But what you see here is the environment, and at the end of the workshops, those physically here can also take a tour with us, a short tour. So this is, on the one hand, the indoor environment, but we also have an outdoor test field for different application domain, in this case, the mobility, transport and mobility. And this tangibility aspect, as it is reflected in the name of ZEKI, is to use this environment as a place where we can provide interaction, the visibility, more tangibility of AI, but also include the explainability aspects. So explainable AI is one of the work packages and activities that we also do in our ongoing project, and overall it's an important team for ZEKI. The third layer is the software stack, so it's not just like an environment where we bring people together, where we do such kind of activities, but this place also hosts lots of researchers like ourselves, and the driving force behind this, especially when it comes to ICT development, software development, research and development, it's Technical University of Berlin, and particularly the DAI lab, the Distributed AI lab, which is a chair at the university, headed by Professor Albayrak. And many of us are affiliated with that. And we have also an affiliated institute of the university, a non-profit organization, GTR Gemeinnützige GmbH. So we have these two entities which have been driving this institute, the new institute, ZEKI, forward. And it's relatively new. It's been about 2 years that we had started. This was whole construction site, and it's been evolving over time, where we embed new projects and new technologies, and the space itself is also evolving. And finally, this platform economy is bringing everything together to try to bridge stakeholders, their assets, creating data sets, make them reusable and useful for everyone. As a start, at least our focus domain has been the mobility domain. That's originating from a very large ministry-funded project called BeIntelli. So BeIntelli project is all about connected and autonomous driving. And there we had done infrastructure digitalization here at the Berlin City Center. And then this space emerged out of that as kind of the control center first for that place, and then also as a showcase, which then extends in the smart spaces and workplace of the future concept with another project that we are now currently running with the Ministry for Labor and Social Affairs, BEMAS in Germany. And now we have also a group working on cybersecurity aspects. So it's quite a wide area, but our common team and what ZEKI provides to do are these four pillars. And when we look at this, the main real lab or real lab pillar, as we said, one of them is this autonomous mobility real lab. And what you see here with the green shades is our digitalized infrastructure. So here we have many types of sensors like cameras, LiDARs on the infrastructure itself, parking sensors, road condition sensors, traffic light sensors, which we can digitally get. And with that, we try to improve the perception of the vehicles and improve the safety and efficiency of autonomous vehicles. So that's the Connected Autonomous Driving project, the that brought us. And besides the infrastructure itself, we are also operating a large vehicle fleet with different modalities, as you see. And these are some snapshots. So we, at the beginning of this year, we have started kind of the initial operations of this vehicle, which is, as you see on the top, lots of sensors, so LiDARs and cameras, radars are all installed, and this is turned from a regular 12-meter bus into an autonomous capable vehicle. We are not able to operate autonomously yet on the streets, but we are able to do closed track testing initially. And then later in the year, it will also be doing operation here in the city center, Berlin. And the idea here is also to bring AI and how the vehicle is perceiving the environment and how the decisions are made closer to the public. So there are large displays inside the vehicle. The inside is also transformed in a way that it acts as a showroom, so to say. Then the second real lab, as I said, is ZEKI, basically, and in our ongoing ZEKI project, which brings us together here, actually. ZEKI serves us as the future of work playground and the smart space real lab. So here we are trying to utilize, again, technology in a way that we can collect data, we can visualize the environment, we can make things more smart, even the furniture, like typical furniture like desks and chairs, to put sensors on them to make them personalizable, adjust your settings, etc. So we have activities around all these themes, which are still ongoing as part of our ZEKI project. And for the remote audience especially, I can at least show this slide with the pictures of different rooms, areas, which we try to make as a very attractive, modern working environment. And here we have the multi-sensor, for instance, which we deployed in all rooms, developed by our staff here, our researchers and students, which can capture many different types of values from the environment, like noise, air quality, temperature, humidity, etc. And also the chairs can detect certain things, occupancy, warn you if you have been sitting too long, etc. So that's in a nutshell, and this is an environment which originated from ministry projects, but now we also have members supporting us, and the members that we are cooperating tightly in our activities at ZEKI. Then the main project which this workshop is about is this so-called ZEKI project, and you are familiar with these, at least for those who have registered through meetup page. The ZEKI project, the name was originating from Gemeinwohl-orientierte KI, künstliche Intelligenz, or AI. So it's like a wordplay saying go AI. And it's representing the aim of the project. So the realization of public good or common good AI applications. Now we started calling this more common good, actually. So the idea here is to support AI applications for the common good, and our project is trying to facilitate this. Those who have very nice ideas, which may benefit to society, but are not AI experts, are not human technology experts, how we can support them with software tools even, but also environments like these to inspire them, and also facilitate the tools with the tool set for them to realize their ideas. So we have, together with the ministry, they must also activities in a way that they have some teams with those ideas where we do those consulting sessions, and we try to support them also along the way. And this project is part of the ministry's program called Work and Society to 2040. So it's on the one hand about the future of work concept, Work and Society 2040, and as part of that, common good AI. And just like the approach in ZEKI, we have designed this project also in a way that it addresses exactly these 4 pillars, which lies at the basis of ZEKI approach. So on the one hand, as we said, the real lab environment, providing an experimental environment, a playground where we can deploy our applications, collect data, do testing, etc. And ZEKI is serving as our real lab in this context. Then the tangible AI part, where we do explainable AI research, and what we focus on in the workshop today is focusing on this pillar of the project. And then we have another work package focusing on software stack, software application development, but mainly to support those people, the society, with nice ideas, but not so much technical knowledge about AI and application development. And workshops like these are part of the platform and ecosystem that we are trying to build to support all of this. I think I already took more than enough time. Without further ado, I will give it to Nils Broya, my colleague, who will present this paper about explainable AI. That's yours. You got mine.
Okay, then thank you. I would also welcome you again here at the ZEKI or in the Zoom room to the first session of our Berlin Explainable and Tangible AI group. Today we will have the first paper reading session, and I will present the paper AI Transparency in the Age of Large Language Models, a Human-Centered Research Roadmap. The paper was released last year in 2023 by Vera Liao and Jennifer Wortmann-Van Garn. They are both well-established researchers in this field and currently work at Microsoft. So in this paper reading group, like in general, we will present different papers. So not only from explainable or transparency, and also not only from large language models, but also from future of work, smart and easy software development, and many more. And yeah, this should be a place where all citizens can come together, even if they are not AI experts and students, so to have a discussions about these interesting topics. Okay, before I want to go into the paper, I want to first motivate a little bit why I will present these papers, what role do large language models play for common good AI applications. So throughout the ZEKI project, we accompanied many idea competitions like the Civic Innovation Camp or Civic Innovation Platform. These are competitions hosted from the Ministry of Work and Social Affairs. And in these competitions, there could people from many different backgrounds pitch their ideas for common good AI, and then get funding and a guidance for developing their idea. One takeaway was that many ideas involve in some way large language models. So for example, people want to use or build conversational agents that help get information quicker. So for example, a conversational agent or a chatbot that helps refugees find information, how they can get information for asylum stuff. Yes, so why do we see this trend in LLMs or the increased use in LLMs? So these are just some reasons that I came up with. So you don't have to agree with me on that. So so LLMs are on vogue right now. They're everywhere in the news, and probably for many people that have had these ideas, they probably have, and consciously, it was the first time that they actively interacted with AI. And these conversational agents seem very human and natural, and therefore the threshold for people to interact with them is quite low. Of course, this usage of large language models right now is also connected with a lot of harm and possible risks, and especially in the common good AI domain, where the target groups are often already marginalized and discriminated people, it is crucial to minimize these risks as far as possible. Oops, sorry. Yeah, so we have to have a deeper understanding why or how these large language models work to make sure that the output that they give is correct and faithful. And yeah, so this is also why I want to present this paper, and why this is important. I want to show you a small interaction that I had with the large language model BART from Google. I think now it's called Gemini since last week. So all I wanted was a statistic that showed the increased use for large language models in our everyday life. So it gave me some numbers from a report which says 37 billion by 2027, and also some examples about the increased use. So far, so good, but of course I wanted to double check these numbers, so I searched for that report, but all I could find was a different, a report that showed different numbers, so 37.2 by 3030, so a little bit of a differences, so I was a little bit suspicious. And then I asked about a follow-up question, so if it could provide me with a link to that report. Then surprisingly, the number changed to 35 billion by 2030. And if I wanted to click on that link, the link was not available anymore. So you couldn't access that report. So now we see we cannot really really be sure which number is correct now, because they are changing. The output is inconsistent, and so we don't know if these numbers are just hallucinated, or if this report or this link was working some time ago. So yeah, this is just a small example of like a toy example, and now imagine if this would be a chatbot, or would be used to access or assess refugees and help them to find crucial information that could actually impact their life. So we need to find answers, and transparency method and explainability methods for that. Okay, so let's look at the agenda, what we want to do today. We can check the motivation, and then we will now go into the paper. So I will first present challenges and problems of for large language model transparency that the authors introduce, and also the existing approaches for large language model transparency that are mentioned in the paper. And then afterwards, I hope we're having an open discussions, and also hopefully some new ideas to take home. So before I'm really going to start with the challenges, I want to quickly emphasize and introduce this term human-centered, because this is an important part of the whole paper. So what we will see throughout the whole paper, and also during the talk, that not only AI developers want to know how and why an AI application acts in a certain way, but also the person that uses the chatbot of its local government. And now assume that person is also not an AI expert, and then their needs for AI transparency differ significantly. Therefore, a new research field has emerged that combines finding from human-computer interaction, artificial intelligence, and explainable artificial intelligence research. This is sometimes called human-computer, human-centered XAI. And because of this increased usage of large language models, we have to take these thoughts into account, so that different people have different needs for AI transparency. And then the goal should be to enable all relevant stakeholders, so all people that somehow are connected to a machine learning model can form an appropriate understanding of the inner workings and the behavior of the model. And exactly that's also the standpoint that the authors take. So every time they are introducing a challenge or a problem, this is always done from this human-centered standpoint. Okay, let's look at the first problem of the paper. It's called complex and uncertain model capabilities and model behaviors. Before large language models became popular, AI models were mostly trained on or built for a specific task, such, for example, object recognition. There's algorithms that can detect a dog or can classify a dog in a picture. Or if we stay at this language domain, there is one task with sentiment analysis where I give a sentence into a model, that movie was really trash, so the model classifies the sentiment as negative. But now we have models that seemingly can do a lot of tasks. So this is an example from the OpenAI chat GPT. So this is just some things that it can do: grammar correction, explain and generate code, translate stuff, and they are on a daily basis emerging more and more capabilities through some fine-tuning or prompting, which we don't even know of yet. So the problem with this is that the usual way to build a transparency around a machine learning model is to analyze the task and then build some suitable method for that task. And this is therefore no longer really possible. Another challenge in that regard is that we often see this unreliable and inconsistent behavior. You have seen it in my motivational example. So it can be that a model for the same input that it gets gives out a different output. And this means that the idea of explainability often was to have this or to analyze this input-output relation. So we have like a specific input that gets us an output, and then we analyze or build explainability around that. So the transparency was, if you put something into the model, you probably get something out of the model. So if that matching is no longer possible, then current XAI approaches are difficult to achieve. Then the second problem or challenge are the massive and opaque architectures. So due to the sheer complexity of the current large language models, so GPT-4 has roughly 1.8 trillion parameters. That's a number that probably the mind is not capable to really grasp. It's become unrealistic to really build transparency approaches that are based on the architecture. So, for example, methods that really investigate the connections of neurons or the weights and the parameters is unrealistic because they quickly reach their limit from a computational point of view. And another problem or the underlying problem is that these transformer architectures, which are at the heart of these large language models, are not yet fully understood. So there are some XAI methods or some explainability methods that try to explain these transformers, but there are different interpretations, and they are often contradictory, these XAI methods. For example, the interpretation of the importance of attention weights is still up to debate, if there's really a causal link between one word and then the output of the model. Massive and opaque are not only the architectures, but also the training data. It's known that many large language models are trained on Common Crawl or all of Wikipedia, but we do not know any details about the data format or the data pre-processing steps. So this makes it impossible to really analyze what goes into a model and what is therefore the basis of the prediction of the model. And also the sheer size of the training data set is also difficult to analyze. Also, yeah, we can't really build a deeper understanding because we also see not so much information that is brought to us by the company. So this is, for example, an excerpt of the Llama 2 research report. Llama 2 is the large language model of the company Meta, and all that they release basically about the pre-training and about the training data is only these two small paragraphs. So there's not a lot to really form a deeper understanding. This brings us exactly to the third problem, which is perhaps the biggest obstacle for achieving transparency for these large language models and the commercial language models right now. It is the proprietary technology. And this means that the large language models are developed and owned by big tech companies, and they will not release their inner workings or secrets of their models. And therefore, we cannot have an independent transparency analysis because the internal processes, the parameters, the weights, they are all behind APIs with which we can access the model. So until this changes, all of these approaches, so these small-scale XAI methods for transformers, they are interesting to have basis knowledge, but they are they are also a little bit pointless right now because they cannot be applied to the real deal, basically. Now, the last problem that the authors mentioned is called expanded and diverse stakeholders. This is goes into this direction of this human-centeredness. We see here, these are 5 different stakeholder groups that in the explainable AI research have until now have been defined. So we have end users, so people that actively interact with a machine, with a model, then owners, so for example, companies, regulators, so lawmakers or judges, affected, so people that don't actively interact with the models but get or are affected by its decisions, and then developers. What the authors emphasize or argued is that we will probably see or maybe see some new groups here. And what we can already see is that in specific groups, we also have new subgroups. So for example, in the end user domain, we already see new subgroups like journalists or teachers and children or students and school children, which now use these large language models, and they all have different needs for transparency. And also we have new job descriptions. So I think 6 years ago, we wouldn't know what a prompt engineer was. And also we will see in the affected group, of course, more and more people will be affected because it's more and more getting at the center of society. So we have to take that into account when we want to build a transparency approach, that we have a really diverse set of people. Okay, so these were the 4 problems and challenges that the authors mentioned in the paper. And now I want to look at 3 existing approaches that could be a basis for large language model transparency. The first one is model reporting. So model reporting or documentation of a machine learning model has become a common industry practice. So also a common practice in responsible AI. There are there are frameworks from Google and Hugging Face where you can have tutorials on how to make a good documentation of the model. Model reporting means that you communicate technical aspects like the training data, training procedure, some ethical considerations, limitations of the model, and then communicate them. So for example, you can see here one. This is from the Google example, a model part, as they also call for a face detection algorithm. So this is basically structured. We see here the first thing, a high-level description of the algorithm, then some technical details, for example, the input, the output, performance, and then also some other performance descriptions. Again, here it is important to whom the information is aimed at, because probably an AI expert and AI developer wants to know more about the model architecture, wants to have an in-depth description probably of the model, whereas the normal end user will probably only want to know when the model should be used, and probably also when the model shouldn't be used, and some limitations or ethical considerations. So there has to really be put thought into how you describe this information or what information you will give. The problem is that somehow this trend has not yet reached the big commercial large language models. All that we get from them are these research reports or system cards. Here's an example from OpenAI. These are really technical analysis and insights that they give for their models. And the critique of the authors is that it's often like cherry-picked examples of nice use cases and capabilities, and also cherry-picked examples of limitations of harm and all of the things, all of the bad things that the model is capable of. And the problem is also that they put a lot of thought into what they will release here, because they also don't want to risk and harm the revenue of the model. Okay, so let's go to the next approach, which is called communicating uncertainty. This area is somewhat a little bit under-researched and underrated, but it's actually a really important part of bringing transparency to a machine learning model. I will go back to this example of a classification model, so a model that can classify dogs. Their uncertainty is often communicated as I'm 95% sure that in that picture is a dog, for example. But this is not yet done for large language models. Probably because communicating uncertainty is tricky, and also take care of what you say and how you say it, because if the uncertainty is perceived too high, or if you don't communicate uncertainty at all, or even like lie about the uncertainty, then it can really harm your model, or that then people won't use your model anymore. But if it is done right, a user can get really the feeling of self-determination, and they will interact with an AI system with more confidence and trust, because then it can basically just, they know when to trust the model, they know how the model did I close the window? Yeah. Then they can, they know when, in which situations to trust the model, and when to better don't use the model. The question is again how and in what way uncertainty should be communicated, because it has been shown that, for example, percentages, so as I said earlier, for example, 59% is a difficult uncertainty measures, because many people don't really understand or can grasp the meaning behind these percentages. So it's important, again, to use probably different visualizations. So there's one paper from Kat et al. Where they exactly investigate how different uncertainty visualizations affect different people. So this is, for example, one way to visualize percentages. So now you can really have like an idea of how much really 32% is. But there are also different, more mathematical uncertainty visualizations that then probably won't be applicable for everyone. Until now, there is not that much for large language models, so there's still a lot to do. So to investigate, first of all, have some methods that can compute the uncertainty of the output of large language models, but also then find ways to really have nice visualizations that are meaningful to a lot of people. Okay, so the last approach is providing explanations. So of course, explanations or explainability play a major role in AI transparency, and the research field of explainable AI has also become a very prominent role in this whole AI cosmos. But the paper does not really deal with an individual XAI method, and it also doesn't provide an overview of existing XAI methods for large language models, because the authors argue because there is just no real good XAI methods out there that supports mechanistic understanding. What they actually do is they discuss desiderata for large language model explainability. And yeah, I will also provide this meta view. So they argue with this human-centered perspective that, of course, the explanations should follow human-compatible concepts. And one way to achieve this is to actually have explanations with natural language, which is makes sense because if you interact in a dialogue way, then also providing these explanations with a dialogue and with natural language makes sense. And then, of course, the next natural step that probably many people would like to do, because that's it sounds so easy to let the models explain themselves, basically. And we will have a look of how this works out with a ChatGPT example. This is an example from another paper from Hubeck et al., where they analyze the different capabilities. So what we see here is an interaction, and the question is, please translate the sentence, the doctor is here, into Portuguese. Then the ChatGPT, of course, can do that. It provides this translation. Then the authors ask the question, why did you pick the male noun for doctor rather than the female? So they want an explanation why they picked the male noun or the male form. And then the answer that ChatGPT gives is that it uses the male noun for doctor because it is the default form in Portuguese. So in Portuguese, it's the same as in German, that we have different forms, male or female. So ChatGPT explains that it uses the default form of nouns in the translation. And then the follow-up question is, what would be some professions where the default form in Portuguese is feminine? So there's a teacher, secretary, actress. So the rationale behind that is that if we would ask for a translation for these words, that it would use the female noun in its translation. So now they take a new session, so they don't know anything about that anymore. Then they ask, please translate the sentence, the teacher is here, into Portuguese. So teacher should be feminine. And now it answers with translation, which they again take the male noun for teacher. And then they ask again why you've chosen that form. And then they give a different explanation. So the thing that we see here is the explanations sound really good, and they probably also make sense in a way, but it's just the explanations contradict each other. And that's exactly the thing that we don't want to see with this input-output relation, that we want to explain something, because if we let them explain themselves, then the explanations sound really good, but they are contradictory and also inconsistent in their reasoning. So yeah, it does not really look good so far in this explainability area, but so this is just the starting point basically to find new ideas and to find new methods, because right now we don't really have an XAI method or an explainability method that is capable to explain them, and we should not definitely let them explain themselves. Okay, so now we are at the end of the paper. Before we go into the discussion, I want to make a quick excursion to our transparency and explainability efforts that we have in the ZEKI project. It's only taking a little while. So far, we have found that in the project, finding a good XAI model or method for a specific use case is challenging. So, for example, we have in this innovation camp, they have so many different ideas, and in the common good AI domain, it is always that the target group for these use cases are really small, and you have to always adapt the XAI methods. And so we know also that many people that want to have these explanations for their use cases in the common good AI domain do not have this in-depth knowledge of XAI. So there are some XAI recommendations that only take these technical details of the machine learning model and then give out some off-the-shelf XAI method. What is missing there is that they don't have this human-centered perspective. So on the one hand, they don't take into account the target group or what the target group is, and also they do not give any recommendation on how to make an XAI method or the explanation of an XAI method really understandable to the target group, because it has been shown that in many cases you can't just use an off-the-shelf XAI method and use that, because then you really have to tailor it to your specific target group. What we did in the project is that we developed a human-centered XAI recommendation algorithm where we aimed for an inclusive tool so that many people with different backgrounds can use that to find an XAI method that fits their use case best. And what we do there is we ask questions about the target group, about their background knowledge of the target group, but also what kind of explanation they want in their for their use case. And finally, or eventually, we provide them then with a human-centered XAI solution, which means that we, on the one hand, have recommendations for XAI methods, but on the other hand, we also have design recommendations that are based on this human-centered theories. For example, that the explanation should be in some way interactive, or it should be communicative. So to really tailor it to the specific target audience, that people who don't have a specific AI background can find their method and adapt it to a specific target group. And yeah, we have some snippets. So it's in German, but here you can choose your target group. So these are just these 5 different that I've mentioned earlier. Then you can also choose what kind of question you want to get answered. So do you just want to have one specific data instance explained, or the whole model, or do you want to have examples that you have to change to get a different prediction? And in the end, you get some kind of this is just a raw prototype. So we have some XAI methods that you can click on, and then you get also some design recommendation on how to design, on how to communicate the explanation. So do you have some visualizations, or do you have some dialogue form? How can you make the how can you make that interactive? How complex should the explanation be, and how to make it personalizable? And what we see in this approach is that, or what the next aim would be, that we can add recommendations for large language models into that tool, because we now have these approaches, and then we can also add recommendations on how to build a good model card for specific conversational agents, or how you have how you can communicate uncertainty for specific large language models. And yeah, we are extending that tool continuously, and we will also soon provide like links on our ZEKI website, so as many people as possible can check that out. Okay, so now I'm finished. Thank you for your attention, and I hope we now have some a discussion, and you can also ask a question, and I hope I can answer them accordingly.
I have a question. So for the Go AI project or ZEKI, isn't it maybe an option just to build their own LLM? Because I know different companies build their tailored, like Product-Man, GPT, and so an organization like that could provide a framework which is explainable, or better explainable, and then other companies just dock into that and apply to their use cases.
I think building one from scratch is difficult, because you kind of have some hardware stuff. But what we are thinking about is to actually have our some open source large language models which we can host on a server, and then people who maybe wants to build some common good AI application can access that or use that from our servers, where we then don't have these data issues that data that they use is reused in some way. But yeah, that's a thing that we think about and also working on a little bit. Yeah.
My question is like, in which applications right now we are applying this model? Like any product was right now?
In large language models?
Yeah. This is developed by... A reminder from our chat, online chat.
Should I?
The
okay.
questions should be repeated because they cannot hear the audience.
Okay.
The online participants.
So the question right now is where large language models right now are used in a.
Initially, this told us like in the bus something we have this model. So is that like real time we are using, or we are just like in the phase of the development? Like it is deployed on some platform.
So do you,
in some product or something like that?
So I think in our case, in the things that we do, we, for example, use it to build some small applications. So for example, if you walk into the main entrance, we have some kind of wayfinding system where we apply these ChatGPT based systems where you can just easily interact with
like the communication. So if I want to enter in the gates, so like this.
Yes, for example, So it's most of the time it's more this communication aspect is very appealing, but also it's often used in like for example in aggregating different documents or summarizing documents. That's often in many cases.
One more question.
Yeah, sure.
Yeah, in terms of monetary, what are the expectations from the stakeholder and investors who are like investing in this project?
I don't know if I can answer that because I don't know actually.
You repeat the
question the question was how monetary wise the investment that people or companies do in this project?
This project is actually a ministry funded, so government funded project, 100%. So there's no industry money involved in this, and it's aiming really for this domain oriented or common good AI applications. So I don't know. It's hard to answer also with outside of the scope of this project in general, funding or interest.
It mostly will be used for the general government and municipality things.
At least within the duration of the project, there is no direct usage in the government. But what the ministry wants us to do is to, with events like this, to present the activities to external stakeholders, but especially in this civic innovation platform of the ministry, which the ministry itself is trying to run. They are having these open calls, which anyone can participate with your ideas. So some idea that you want to realize can be in any health domain, in any topic of public interest. Then the ministry selects some of those and tries to walk along with those to try to support realizing those ideas. It doesn't have to be only in the future of work domain. It's more open than that. And they're also within this project working with us, where we try to support, as I tried to say at the beginning, with software tools and frameworks to realize those ideas, but also with question and answer sessions supporting them. So this project is more about supporting the public with such AI application development, especially towards non-experts.
Maybe a contribution. So far, I know that there are some companies that actually have some models, for example, Aleph Alpha or Mistral, that at least have an Apache 2 license, that also with business corporations, they give out the model, so it's at least touchable to some degree. And especially Aleph Alpha, on their website, at least they have an approach and a paper that provides contribution or attribution to like input with respect to what they output. So that might be something or the right direction to actually at least have some kind of explainability more in the terms of saliency methods rather than real text, which is of course more human-centered. But maybe that is one direction or one glimpse into what could be available. But my question would be, so if we have such a contribution, so what is this enough, or is there something that we can say, okay, this brings us to this point, and what could be next, or what could even be better than just the safety or attribution?
Yeah, well, with these, I think if you have something that, do you mean the saliency, which token is important, most important for? Yeah, I think the problem is that in many cases, these are still difficult to really interpret, because, for example, if you have, I've seen this example that we have some kind of word, or we have a sentence, and then we see, okay, this word is really dependent on that thing, for example, but it's still, and then I don't know, in a different way, we see and other words are dependent on other things, then it's still, I don't know, what does this mean still? How can we interpret, or the reasoning behind it is still opaque, I think. So we have to have some, I don't know, way to really explain also what these saliency things mean a little bit more, and interpret them. Yeah. So one thing that in the paper, they also go a little bit further and really ask some questions if we really have to rethink these whole objectives of how we right now build XAI methods, which are mostly based on these saliency things, because even in these easier examples for image classification, that they don't mean much often, or they are not very helpful. And now for example, this human-centered, then we should probably reevaluate our approaches of objectives for XAI. Yeah.
Do you have any idea or information about like how we could, so the solution would be probably some kind of causal model behind it that we could then use to directly say this is the reason behind this outcome. Do you know of any kind of methods that could help us to at least approximate these causal models based on, for instance, something like a saliency map or perturbation methods?
Yeah, so I don't know of any, but the thing is, with causality itself, I was working a little bit on that, and there are so many things that you have to pre-assume and have give or pre-assume like causal relations of language, basically now, how different sentences are causally structured, basically, and I think that's a really difficult task to achieve. So I don't know if of any, right now.
Yeah, question is.
Yeah, okay, so we had one behind that, but you can,
The question or the contribution regarding explainable AI, is there any overlap with the technical writing community? Because you mentioned that it's still an issue or problem, that you have a lot of different stakeholders and you're not sure which method to use, or that it's like fizzling out in terms of what tools you have. In technical writing, you also have this issue, especially with consumables. If you write a manual for consumable, you have a whole range of people, and you don't still want to write kind of one manual and not 10 different. So I think there's some experience with dealing with this kind of variety of target groups.
So I repeat the question. The question was if there's some overlapping action with technical writing, if I'm correct. And so I don't sure if I understand it correctly, but I think there is not really one of the main critiques of this whole XAI approach that is a lot really algorithm centric and only like it's always called the patients running the asylum, that only AI experts build XAI methods for themselves, basically. But there are right now many approaches that try to add this easy language, so einfache Sprache, into probably these XAI methods, so that as many people as possible can comprehend it and understand it. So there are some ideas to add that. Okay, you had a follow-up?
Yeah, maybe it was unanswered already. So I was just interested in your personal opinion, how it could be more like confidence score, like for object detection is a very easy way. You can do something similar for this, that the GPT says like 50% certain. But I was interested in your personal opinion, what could be a good way, but maybe it was answered already.
Yeah, the thing is with this uncertainty is, I guess, that for these classification, to communicate uncertainty, you first have to have some method that actually measures that uncertainty. And there are approaches that do that, but they are not yet applied into this XAI domain. But I don't know, probably if I would add something like that, maybe if you have you ask something and then the answer comes, and then you can ask how sure are you, or why did you answer like that, and then you can output something. But you could do that right now and it would give you something out, but you have to have something different. So
would you think maybe to add a layer on top? Like, I mean, we do these checks like you showed, we check the link or check if there's a link, where is the information coming from, check is the link consistent with it. So we could add a front-end AI doing all these checks for us. Or do you think this will create more hallucination or?
Yeah, this could work, but I'm not sure. I think there are some approaches where we have this human in the loop alignment approaches and efforts where we basically look how we can or check if the output of a model and the reasoning behind a model really aligns with the way that humans would reason or come to an output. I think that could be some effort. Yeah.
Maybe just a response to that. So if you're looking at Bing and their Copilot implementation on the website, there is actually some kind of glimpse into how you could solve it, because they actually have a trivial augmented system. So basically, you have like a chatbot system. They do research, they augment the response by that search result, but they also display the sources where they actually use information from. So it makes it easier for you to then just click on it and verify, especially where the information came from. Of course, now you could think about creating some kind of additional AI system that does this check as an additional layer on top. So of course, it doesn't provide you 100% guarantee, but you have at least another security layer. And I mean, that's how we typically also in computers create like certainty when we have noisy environments. You know, we just stack additional methods on top until the probability that something goes wrong goes so low that you will probably have errors from other sources that are bigger. But maybe that is some kind of like practical approach.
Yeah. Yes.
With this issue of uncertainty, is there any reason why these systems don't ask questions usually? Because I mean, they make so much of a thing that they imitate natural conversation, and the first thing, if you're not certain about an answer, is to ask back. And I think that is that a design thing that they always seem to be so certain, or is it a technical thing?
Well, I think
that strategy. I mean, we had this discussion the other day. Why this ChatGPT doesn't ask questions if it's not sure?
I think it's often built as being an assistant, so that it only does thing that you want. But yeah, I don't know. You can probably prompt it in a way that it also asks you stuff. So I think
if it needs extra information to be able to answer the question, it does ask questions, but this is natural. I mean, of course, it doesn't initiate conversation.
I think it asks questions if it doesn't understand the prompt, but if it's not sure about the result, that's, I think, that's always presented.
Yeah,
that's that it's very sure.
That's
never says, it could be this or this, or
yeah, good point.
Yeah, true. Yes.
Well, I hope, thank you for the presentation. I hope I understood your presentation, all the questions that the other people have asked. But to me, it appears that most of the topics we are talking about are directly or indirectly related to the whole structure of AI ethics. Now, as far as I know, I do not know of any organizations who have standard AI ethics bodies within their company, within their structure. Or if they do, they are limited to only the technologically educated individuals or who are already developers. But are you familiar if there are any practices which can help me understand how do the technology teams ensure that the ethical questions such as uncertainty or human centricity, how are they met?
Yeah.
Because if they already know the answer, the defect would not rise in the first place. But naturally, if there's a defect, it means that there was no third-party view to the solutions they provided.
Okay.
So what's your take on that?
The question I repeated was that if there are any organizations or bodies in companies that make sure or have some ethical background and not only the technical background. So what I can say is that actually she is working at Microsoft Fate group, and Fate, I think the E in Fate is for ethics. And so there's one body in Microsoft, and also the paper is really critical written. And also were also some researchers from Google that critically wrote papers and therefore also got fired. So there are, I think they have some ethical bodies and subgroups, but then they always they make some videos on how they can do that, but that's probably maybe also a little bit greenwashing. And yeah, as some examples exist, if they are too critical for their own models, then they are no longer employees. So yeah, this is a problem, and I think also this in the paper it's getting quite clear that this proprietary technology, that these large language models are owned by private companies, and we don't have the possibility to have an outside analysis or an outside ethic analysis. That is one of the biggest drawbacks to achieve transparency.
So does that form, by any chance, do you consider that as the fourth pillar in ZEKI? Because the fourth pillar,
yeah.
if I understood right, it's about participation, it's about engaging with external stakeholders who may not be technologically educated or
yes,
technologists.
Yeah.
So do you foresee, or is that already a plan that to engage with people who are ethicists, trained ethicists, or?
We don't have the plan to work with ethicists per se, but what we are planning and what we are already doing, well, this fourth pillar is more concerned with citizens and the public as a whole. So, for example, if you want to, we now offering like ZEKI tours, where we especially want to emphasize on these problems that there are, and probably break down some barriers or some anxieties that people have with AI, and people can book tours here, and then we show them what we are doing and how we are seeing these problems and these things, and that's our approach for that problem. Yeah.
With that, we also would like to collect feedback, and I think from the ethics perspective, all kinds of feedback are also welcome. So this community perspective is open and can and should include also this.
Then you see
Yes,
sure.
This transparency seems to be only kind about how a model works or what is a model. Does this project provide also some transparency in the effects of the model, for example, social or environmental effects?
I repeat the question. It was it only the transparency in the paper only concerns like the technical parts, so the inner workings, and if we in the GOKI project also have some societal ethical aspects. So I think the transparency thing as a whole is like a huge topic, and ethics is also a subpart of that. And the thing is, I'm not have not a philosophical ethics background, and I only I think that's also probably maybe something that we all have these technical backgrounds, and then we always stick only to analyze the technical things. So we are not in the GOKI project specifically investigating how these models impact society per se, but we try to open it up to society more. So we want to have this broader access that everybody can access these methods, or can develop their own methods, even if they are not AI experts. But we in our group, we do not investigate how, for example, the use of large language models changes society. I think there are other university groups that have more expertise in that regard. And yes, but it's a super interesting topic that should definitely be combined when we talk about transparency and ethics.
Not even environmental effects, because that seems a bit more technical.
Environmental, when we talk about we talked about these competitions, these idea competitions. There we accompany and consult ideas that also aim for these environmental or use AI to have some better environmental impact. So we are more of a consulting people that have these ideas and not have them or investigate these things ourselves. Yeah.
And the point also is that the projects, work packages, the activities are mainly, I would say, at kind of the meta level, so providing framework and tools and explainability methods or methods to find a suitable explainability method for an AI application developer. So they do not directly address a use case that may have a negative environmental impact, so to say. There are, of course, many applications specific applications, use cases, which can then come on top of the tools and things that we develop. That's a separate topic that we are not directly addressing, but as Nils said, as part of the groups that we are accompanying and supporting with these ideas, there are those looking at how we can make an environmental impact in a positive sense using AI. But of course, there's the other side of the coin, the environmental impact of the AI itself, which is getting bigger and bigger, especially with LLMs, computation power, the environmental impact of that. That's also, I would say, a different research track activity area, which we are not addressing.
Just a remark, because I found your remark quite interesting. So about these ethical parts in companies. I think one way to go is actually to educate the society about the need for that. Then biopolitics make that a requirement. Yeah? So like in the medical field, where we also have ethical committees that decide if something is viable, if a product is safe enough to be actually sold. I think this is a crucial aspect that we need to make a requirement towards these companies, so that they have a reason to actually have these departments and these people that take care of it, not just because they want to have a nice marketing around it, but actually with a real impact and a real reason to do this. But that is something that I think via education and by spreading these ideas and these needs into the whole society, that is, I think, a good way to get to that.
I have one more question.
Yes. No, you go first.
Okay, great. This would be a tricky question. So your goal is to have a transparent AI system. So when you have a transparent AI system, according to the trustworthy AI framework, there is always a trade-off with technical robustness, because when you have to compromise on all the 7 requirements which are there. How do you balance that? And how would you, if you're focusing on transparency, what is your answerability to the remaining 6 requirements?
What 7 requirements? Sorry,
So the trustworthy AI framework for you has 7 requirements.
Yeah.
So,
okay.
So transparency is one of them.
Yes, yeah.
So if a particular AI system is transparent, then the document says that you have to compromise on technical robustness because the model is very transparent.
Yes.
So which means there has to be a balance. And the document also says that you should be able to, if there's a trade-off, you should have relevant mechanisms to ensure that the robustness is not completely compromised. How do you do that at ZEKI?
Yeah. So the question was if we so transparency is one pillar of these 7 components of the AI EU AI Act, and if there's some balance, so if the transparency is high, then probably the performance will be lower. Yeah, so the thing is with these XAI methods, they can be applied to an exist. So, for example, if we have if we stick to these, for example, not large language models, but I don't know, image classification model, there are explainability methods that can be applied to that model. So the model can be explained to some extent. So there's argumentations that are these explanations really helpful and stuff, but that's a different topic. But we can make it transparent and reason a little bit how the model works without the performance going down. So there are methods that can do that, but for these large language models, we don't have these methods yet. So we we probably would, if we want to have some dialogue form or some chat engine, then we can use some, I don't know, some basic natural language models or natural language processing models which are old and are not so natural and human-like like ChatGPT, but they are explainable. There you're right. So these are explainable, but the thing is now that the goal is, and we are only at the beginning of that trajectory, to build these XAI methods for large language models, so that we do not have this, this balancing, this trade-off, exactly, Okay, yes.
My question is like, what are the future plans, like future enhancement for this model LLM? Are there like several versions with some advanced features, or you are just stick to this particular one model?
The question is if there are any new, or what is the next steps for large language models. So the thing is, maybe you have to go to like an OpenAI website or something and look there at the newest things that they are doing. Probably if I would know what the next step is, I wouldn't be working here, but at Facebook, or I don't know. Yes, they are doing, for example, the newest thing is that you can put a text and then it gives you out a really good looking video and stuff. It's more concerned with these new, so there are always new steps and new interventions that can be done.
It's like you are just open to any other projects or ideas which is relevant to the LLM, so you are going to be integrated also.
Yeah, so the thing is that I think that we are trying to do is use this technology in a responsible way to infuse it to some of our interests in our work, in the work environment, for example, in the automobile, self-driving, autonomous driving thing. So we are more concerned with using the technology in our research. Yeah.
How you find out, like in that presentation you mentioned that there are lots of hidden LLM models which used by government or military. So how you can find out this kind of information? Like this kind of models are present.
I'm not sure. Did I say that? So they, I don't know, just reading or in some internet forums, or like reading these research paper, you have to, yeah. Yes.
I think I didn't think it's original, but the AI Act stated that there needs to be a transparency, that people need to know if they are engaging with such models or chatbots. So it should be, or at least in the European Union, in a couple of years, it will be a law that you will be aware.
It should be like more.
Yeah.
Yes, welcome.
I have a question, maybe not specific to the Go KI project, but to ZEKI.
because you talked about the autonomous and you apply what you do here also there.
Yeah.
So what is your role there? Do you just provide the infrastructure or you develop the bus and this hard? I mean, not the hardware, but the software to drive autonomous and to have these sensors and all the control software.
Yeah. Yeah. So the question was, what's the role of the ZEKI and the people working here, and if we are developing these systems? So yes, basically, if I am correct, then we use this. So the hardware, for example, we have this bus from MAN, and then we develop the software for the self-driving component and also these explainability parts. Why does the bus act the way it does? So yes, there is this BNTelly subgroup, so not the GoKI group, but the BNTelly group that does this whole software engineering and research on that. Yeah.
Okay, so like a turnkey solution for a sector hardware, like the control, like a turnkey solution. So like the whole software, sensors, control, everything.
I have missed the beginning of the question, but what ZEKI does, I think it's correctly stated, and this software stack that we develop is something that very competitive because it's done with mostly government funding in the Green project first, but then the industry also does follow-up projects with us, cooperation projects, and we have that with MAN, with Mercedes-Benz. For instance, Mercedes-Benz wanted to also bring the EQS, their modern vehicle, which has actually level 3 driving license in Germany. So that means they already have their software, the sensors embedded on the vehicle, their own autonomous driving. But they wanted to test with us also our sensor configuration. So now we are equipping the vehicle with additional sensors. We're using our reference architecture of the sensors and also putting our BNTelly software stack, and then do like comparative tests and using the infrastructure also to see how it interacts with the environment. So it's kind of a ready solution, but it's not like a product that we market or sell. It's giving grounds for cooperation with industry. But the software stack and the solutions that we develop itself is something that we use for further research and development.
Okay. Yes. Then I think we can end it here. Thank you all for coming. It was a nice first session, and I hope you will.
Thank you very much.
So the next meeting would probably be sometime in March, and we will always communicate it over meetup.
Should we make it 2 weeks again? Yeah, for anyone interested or has the time.
Sehr schön strukturiert, eingefüllt und so.
So let's